Now, on the last video lecture series, we actually talked about the combinations of matter, both physical and chemical. So we talked about things like homogeneous and heterogeneous mixtures, solutions, suspensions, and basically mixtures as well. We also talked about pure substances versus compounds, and then we talked about the molecules, which are the smallest unit of a type of substance, and we also talked about the chemical formulas which are used to represent them. Now we're going to talk about chemical reactions and why atoms actually form these molecules that we talked about, or compounds, or pure substances, or whatever. Now remember the basic structure of the atom. It's got a nucleus, which is going to have protons and neutrons inside of it, each made of quarks held together by the strong force, and then the whole nucleus is held together by the residual strong force, and then the atom is held together by electromagnetism because the negative electrons are attracted to the positive nucleus and by electromagnetic charges. Now, each of these atoms will have electron configurations. For example, this particular guy over here, it's got 6 circular electrons. We're talking about carbon, and it will have 4 electrons on its last shell, and it wants 4 more to be happy, or it wants to give up 4 to be happy. And you see this one over here, though, all right, which has a completed shell, like it has 10 protons and so forth. You're going to have 2 electrons in the first shell, and then 8 electrons on the last shell, which will give it a complete shell. And that's a noble gas that we're talking about here. And yet another noble gas you see there. Now remember, the advantage of being like this is that it will have electron stability. This particular atom here will never have an area of the atom which is more negative than another, because the electrons will be distributed throughout the atom in a way that you're always going to have the same amount of charges everywhere in the atom. But if you have more or less than a complete shell, you're always going to have a transient charge, which makes the atom heavier on one side than the other in terms of charge. So sometimes they will have more charge here, sometimes they will have more charge there, depending on the moment you trap it and where the electrons are in that stage. Now, that means that atoms will try to connect to each other in order to make themselves happy. Now, let's look at the classic example of this, and we're going to start by talking about ionic bonding. Ionic bonding. Now, right off the bat, I'll tell you this is one of the most strong types of bonds that can happen between two different atoms. And it will happen that strong because it will create an electromagnetic force between the two atoms as they become ions. Now, we talked about ions before, but let's just do a review. Now, notice that this particular atom on the left side here is going to be sodium. Now, sodium will have 2 electrons on the first shell, and it's going to have 8 electrons on the next shell, and then 1 electron on the shell after that. And it will have a total of 11 protons on the outside, and then it's going to have 11 electrons on the outside. So you're going to have 11 negative charges, 11 positive charges. It has an overall charge of 0. It should be happy, but it's not, because that single electron that's sitting by itself over there is going to create a transient charge. Wherever it is, it's going to be more negative than the rest of the atom. And it doesn't like that. Now, chlorine over here on the right side is going to have 17 electrons. And so with 17 electrons, chlorine will have all these layers filled in. And on this last layer, it's missing only 1 electron to be happy. But as it is right now, it's going to have 17 protons and 17 electrons, and therefore also have a charge of 0. But it will have a transient charge, since one side is always going to be having less electrons than the other, since it doesn't have a completed shell. Now you see, 1 more electron will make chlorine have a completed shell. 1 less electron will make sodium have a completed shell. So sodium looks to chlorine, chlorine looks to sodium, and then it goes, da, 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 da. Cuban romantic music. They look at each other, it's love at first sight. Chlorine says, give it to me, baby. Yeah, Sodium says the same thing, you know. All right, I will give it to you, no problem at all, because I want to give it up. Chlorine says, yes, I want to take it. I want to give, I want to take. So take it, give it, take it, give it, take it, give it. And they actually do. No, atom love. Basically, sodium gives up 1 of its electrons to chlorine, and then this electron will jump to chlorine. Now, when that happens, what happens? And that's what you actually see in the next picture here. You see that this electron is going to be jumping from the sodium to the chlorine. Remember, this is also going to be happening because chlorine is more electronegative than sodium is, while sodium is metal-like. So sodium is a giver, while chlorine is a taker. So they are happy together, you know, so happy together kind of thing. So when that happens, though, what's going to happen? Well, when you transfer the electron, basically sodium becomes positively charged. Why? Because remember, the inside of the nucleus of sodium, it's still sodium. So you're still going to have 11 protons on the inside here. Remember, what matters is on the inside. Chloramine is still chloramine because it still has 17 protons. But now chloramine has one extra electron on the outside, which means it's going to have 18 negative charges. And sodium is going to have one less electron on the outside, so it has 10 negative charges, which means this is going to give an overall charge of 1, or a positive charge for the sodium, and an overall charge of -1, or a negative charge for the chloramine, which means that now this is called a chloride ion and a sodium ion. This is called a cation. Remember, cat, the T looks like a plus sign. That's how you remember. And this is going to be called an anion, the N for negative. Now, positive and negative attract each other, don't they? So there's going to be an electromagnetic force, which is going to be attracting these atoms together. Notice, by the way, that sodium got smaller and chlorine pretty much stayed the same size. But sodium got smaller because it lost its Lex cloud, which now looks like the cloud of the noble gas, and so does the chloramine cloud. And so they're both happy, electrically stable clouds, but now, in an attempt to get rid of a transient charge, they gain an actual charge. So that's, oh, bummer. See, that's what you get for getting involved in relationships. You're trying to get rid of a problem, you start getting another problem. Well, think about it. In relationships, what you got to do is you kind of complement each other. So the sodium says, well, I have a positive charge, you get a negative charge. If we stick together, we cancel each other out. So the sodium and the chloramine will form a unit where the positive and the negative will cancel each other out, and overall you have a zero charge. And you form something that's called sodium chloride or table salt. And that's the love story that makes salt. And this is basically an example of an ionic compound, which is basically created by electron transfers between a metal and a non-metal. So whenever you have an atom which has very, very strong electronegativity and an atom that's very, very strong metal-like properties, you're going to have likelihood to form an ionic bond where electrons are transferred. Here's another example of that. This is an example of where the magnesium atom wants to be happy now. Now, remember, magnesium, it has 2 on its last shell. It's an alkaline metal. Now, it needs to give up those 2 to be happy. So chloramine says, you know, sure, I'll take 1. I'll be happy with 1. But magnesium says, no, please take another one. I got to get rid of 2. And the chloramine says, no, I'm sorry. I just need 1 more. But, you know, I can call a friend and we can work this out. 2 of us, 1 of you. Sounds good to you? Magnesium says, oh, this sounds very good to me. Then I'll get rid of my 2 electrons and, you know, I'll take care of both of you at the same time, kind of thing. And then he says, all right, so I'll give you an electron, I'll give you an electron, and then what happens to magnesium? Magnesium now gave up 2 electrons. So now it's going to have 2 more protons and electrons, and it gets a positive charge of 2. So it's going to be 2 plus now. Now each chloramine is going to have 1 negative charge. And these positives will attract the negatives, and you're going to have electromagnetism here, again, holding this whole structure together. You made MgCl2, right? Magnesium chloride. So you see how you actually created, or magnesium dichloride in this example. Now remember, this is a molecule of that kind of salt, all right? And you can tell by the subscript saying 2 that there's 2 chlorine atoms in that particular molecule, all right, of salt. Now, you see then that whenever you have atoms which need to give up more than 1 electron, they might need more than 1 atom to actually combine if that atom can only take 1 electron. And it gets more complicated than this, and in chemistry class you'll learn about this kind of stuff in more detail. But for now, what you need to know is the idea of a covalent bond, which happens when electrons are transferred between atoms, usually a non-metal, for example chloramine here, and a metal like magnesium here, and there's going to be a very strong difference in electronegativity between the atoms, which will allow chlorine to rip an electron out of magnesium, which doesn't mind at all. everybody's happy, everybody's good. That's an ionic bond. And we'll talk more about kinds of bonds in the next video.